In this lecture, we'll discuss hash functions. We have seen that a hash function is used to generate a hash address from a key. Now let's see some basic properties that a hash function should have. If we have a hash table of size m, then our hash function should generate addresses in this range 0 to m minus 1. A hash function should be deterministic, which means that for a given key, it must always generate the same hash address. A hash function should be easily computable. It should not take very long to compute. So the hash function should be easy and fast to compute. Next, a hash function should generate addresses such that collision is minimized, which means that it should distribute the keys as uniformly as possible. Now, if the nature of keys is known in advance, then we can choose a good hash function that gives minimum collision for those type of keys. For example, if we take social security number as a key, then taking a hash function that uses the first three digits is not a good idea, since the first three digits represent the geographical area, and so they can be same for many keys if the data is from the same geographical area, and hence there will be many collisions. So in this case, using the last three digits can be a better idea. Similarly, if we take date of birth as a key, then using the day of birth is a better idea than year of birth. So based on the nature of the keys, we can try to create a hash function that performs well. So we need a different approach for different type of key. In most of the cases, we don't know the nature of keys in advance. So the general approach is to take a hash function that can work such that the addresses generated are distributed randomly. There are many ways of constructing a hash function. So now we'll see some simple techniques for making hash functions. In all our examples that we discuss, we'll assume that the key is an integer. If we have keys that are not integers, then we can easily convert them into integers. For example, if we have an alphanumeric key or a string, then we can convert it to an integer by using the ASCII values of the characters. Now the first method that we'll see is truncation. It is also called extraction or digit selection. It is the simplest method for constructing a hash function. In this method, we generate an address from the key by selecting some digits from the key. For example, we can take some rightmost digits or some leftmost digits from the key as the address. Now suppose we have a hash table of size 1000 and we have to store some 8-digit keys. Now table size is 1000, so we need addresses in the range 0 to 999. We can form our addresses by selecting any 3 digits from the key, and that way we can get addresses in this range. If we decide to take the 3 rightmost digits as the addresses, then the addresses will be this. So now this key is stored at index 457, this one is stored at 436, and so on. If we decide to form the addresses by taking 2nd, 5th and 8th digits, then the addresses will be this. This method is easy to compute and is fast, but the chances of collision are more as we are not utilizing the entire search key. Now next method is mid-square method. In this method, we square the given key and then some digits from the middle of the square are taken as the address. The selection of digits depends on the size of the table. Suppose we have a hash table of size 100 and we have 4-digit keys. Then we'll need addresses in the range 0 to 99. We square these keys and then take 2 middle digits as the address. So these are the addresses. If we have a hash table of size 1000, then we can take 3 middle digits from the square. Now, if the keys are very large, then this square will be even more large. So, in that case, we can take a portion of the key and perform mid-square method on that portion. For example, suppose we have 9-digit keys. We can take a portion of the key which contains first 4 digits or last 4 digits of the key and then square that portion. Next, we have folding method. In this method, we break the key into different groups such that the length of each group is same as that of the required address, except possibly the last group. Suppose we have a hash table of size 1000 and we have some 11-digit keys. This is one of the keys. We break it into groups of 3 digits. The last group is only of 2 digits. Now these groups of the key are shifted such that the least significant digits of all groups are in the same line, and then these groups are added. Now we can obtain the address of the key by ignoring the final carry in the sum. So the hash address for this key is 625. This method is called shift folding. We can slightly modify this method to get another method called boundary folding. In this method, we reverse all even groups before addition. So here we have reversed this second and this fourth group. Now ignoring this final carry 2, the address is 417. Now let's see division method. This is the most commonly used method for hashing keys. In this method, we divide the key by the table size and we take the remainder as the hash address. This is also called modular division method or modular hashing method. Now if the table size is m, then any remainder will be in the range 0 to m minus 1. And therefore, hash addresses that will be generated will be within this range 0 to m minus 1. So this method ensures that the address that we get is in the limited range of the table. In our program, we can use this operator to get the remainder. We can minimize collisions if we take the size of the table a prime number. This way we can distribute the keys evenly in the table. Now suppose we have a table of size 97 and we have these keys. So these will be the addresses. Now this modulo method can be combined with other hashing methods to ensure that addresses are in the range of the hash table. Now let's talk about the size of hash table. If we have n records, then ideally we would like to take a hash table of size n. But in many cases, the exact number of records is not known in advance. So generally the size of the hash table is different from the number of records. The number of records is generally denoted by n and the size of the table is denoted by m. The selection of the table size will depend on the collision resolution method that we use. Now let's see what is the load factor of a hash table. It is defined as the ratio between the number of records to be stored and size of the table. Now in the next few lectures, we'll study about collision resolution techniques.